Respected judges and the members of SIH evaluation panel, we are the team Tejas and we have built a project for Kochi Metro Rail Limited titled Smart Fleet Induction and Planning System. Kochi Metro Rail Limited is a modern metro system in Kerala, India. It carries thousands of passengers every day and focuses on providing safe, efficient, and smooth travel. Managing metro operations is complex because there are many trains, each with its own maintenance needs, schedules, and operational constraints. Every night, supervisors have to plan which train goes into service, which stays on standby, and which goes for inspection. Proper planning is critical to ensure safety, efficiency, and passenger comfort. Supervisors currently rely on spreadsheet and WhatsApp messages to check fitness certificates, maintenance job card, cleaning schedules, mileage balancing, branding commitments, and stabling positions. This manual process is very slow, fragmented, and prone to errors, making it very difficult to manage quick and accurate decisions. Our solution is a web application that allows supervisors to monitor, analyze, and manage all aspects of a nightly fleet planning in real time. It combines automation with human supervision, making the process accurate, faster, and error free. So, here we have not integrated real data or live systems. We used mock data to stimulate the workflow and demonstrate how the system operates. So, this is the main entry point of the system and shows that all the live monitoring and operational data will be managed here. It acts as a control room for nightly fleet planning. So this section shows how a system connects different data sources. The IBM Maximo for maintenance data and job cards, the IoT sensors for real-time data health monitoring like brakes, engine and temperatures, the UNS data streams for live train operation data like speed, passenger count and next station, the WhatsApp API for field staff updates like cleaning completion or compliance. Here we have the automatic data collection which includes the IBM Maximo EAM integration and IoT health monitoring network. This section shows maintenance and health data of the train. If a job card is still open, the train cannot be selected for service. And here, if the sensor shows abnormal values like high brake temperature, the system automatically flags it. We process this data using Kafka streams and Flink. A rules engine automatically applies constraints to prevent unsafe or unsuitable trains from being selected. And next, we have the operational data streams here. So this panel shows live operations data next to the field updates. So on the left, we see things like train speed, passenger count, and next station. And on the right, we can see the WhatsApp field updates from field staff like cleaning status, complaints, or other real-time messages. So before, supervisors had to check multiple systems, making it difficult to track everything. Now they can see all the relevant data information in one unified view, which reduces mistakes and saves time. Next, we have the supervisor override panel. Here, even though the system suggests the best train selection based on rules and live data, supervisors are still in full control. They can override the decision, change the priorities, and run what if simulation which helps see impact of their decisions before committing. So here they can select the train dataset ID and the override reason, and priority adjustment is selected here, and they can enter the amount of hours this overriding has to be done, and they can submit the override here. So this will ensure that human judgment and next, let's look at the planning parameters. Here we define the daily requirements for the train operations. The required service trains. This is where we set the number of trains needed for passenger service on that day. And job card service threshold. This sets the maximum level of maintenance issues a train can have to still be considered fit for service. Next, the planning date. This fixes the plan on a specific day. So these three inputs form the foundation of our daily induction plan. Next, the planning parameters manual override. Force include train. This allows supervisors to include certain trains in service even if they have the blocking conditions. And next, the force exclude train. This lets them exclude specific trains from service even if those trains are otherwise eligible. So these overrides give flexibility to balance system rules with real world decisions. Next, once the parameters and overrides are set, the operator can click the Run Eligibility Analysis. This checks which trains are eligible based on the rules. And next, by clicking the Generate Induction Plan, the system creates the complete plan for the day. Next, let's move on to the what if scenarios module. So this module help test different combination of parameters and instantly see the result. So here the planners can adjust the service train to increase or decrease the number of trains. Next, the severity threshold to change the strictness of safety checks. We also provide preset scenarios such as peak service for high demand hours and minimal service for low demand or maintenance days, and high severity threshold to allow more trains, and strict quality to apply tougher and safety rules. The complete result compare the current plan with the scenario plan, so planners can easily see the impact of different choices. We can see the test scenario which is given here, and the current plan and scenario plan can be compared by the supervisors here. And next we are moving to the result section. The summary shows how many service trains are available and how many are on standby and how many are blocked and whether there is any shortfall present. So the allocation view shows how the trains are distributed here. The service train, the block train and the standby train in this pie chart. And next we can see the detailed train analysis which explains each train's eligibility, their blocking reasons and the ranking. The ranking system ensures the best trains are prioritized based on usage, balance, branding needs, and maintenance schedule. Coming to the bay assignment, it shows where each train is placed in the depot, considering the space, cleaning facility, and the departure order. So finally, the planners can export their plan as a CSV file so that the data can be shared with other teams or used in spreadsheets. And next, we come to the help and documentation section. So, a quick start guide for the new users and information on data formats are required, and details about the planning logic used, and explanation of the blocking rules and the ranking priorities that guide the train selection. So, this makes the tool easy to understand and use, even for someone operating it for the first time. So Kochi Metro currently runs 25 trains, but soon it will expand to 40 trains across two depots. Managing train planning manually will be almost impossible at that scale. The system we have built is smart, reliable, and easy to use, making train operations smooth, accurate, and fully manageable. So it is a future ready solution that will be extremely helpful to Kochi Metro's growth.